The following systems consist of two functions. Write one or both of the equations, while one or both of the equations may be nonlinear, the system can still be solved by finding points of intersection on a graphing calculator. Please think back to the worksheet we did yesterday. The sibling rivalry, remember that? Think back to that worksheet and tell me what we talked about when we talked about that worksheet yesterday. We talked about a linear equation. We talked about an exponential equation and a quadratic equation, right? There were three different kinds of equations all on one graph, and they all weren't linear, were they? Okay? So even if one of them is linear, we can still call it a nonlinear system because not every equation is linear. Does that make sense? Okay? So, but we've talked about systems of equations before, and when we talked about the systems of equations, where did we find the solutions? Especially when we were graphing. Where did we find the solutions? At the intersections, right? So no matter what shape the equations are, whether it's a line or a quadratic, are you telling me that the solution is still going to be where they intersect? Yes, absolutely. Okay? So if we're looking here at problem number 1, before we even put anything into the calculator, tell me about what you know about number 1. Both of them? Both of them are quadratics. Okay? So in this case, just talking about problem number 1, what are the possible numbers of solutions? Can I get just one solution? Can I get just one solution? If the vertices are right, like touching each other, that's one solution, right? Can I get 2 solutions? How? Oh wait, is this the only way to get one solution, by the way? What about like that? Will this come over here and meet this again somehow? Not with properties of quadratics that we know, correct? Okay, what is it possible to get 2 solutions? Like that? One there and one there? Any other way possible to get 2 solutions? Pardon? That's a good question, but read the first part of this. The following system consists of 2 functions. Can parabolas open sideways and be functions? No. So maybe not, at least not that we can think of right now. Is there any other possibilities besides 1 or none? 1 or 2? 3? How could we draw it and make 3 solutions? Think about that for just a second. I got to write down what she just said. She said all of the solutions. So if one parabola was right here and the other parabola was right here, wouldn't that be all the solutions? Okay. Are there any other possibilities? Could you have no solutions? Could we draw 2 parabolas in such a way that they would not touch? Like that? Or even like that? So several of you nodded when somebody said 3 solutions. I want you to see if you can figure out what that would look like. Okay? In a minute, not right now. In a minute. Okay? So tell me again, how are we going to find the solutions to this system? Graph them and find the intersections, right? So if we're graphing them, I really, really want you guys to work on clearing your calculators when you leave. Some of you do it every single day. Some of you don't. Please fix that, okay? If you need instructions on how to do that, I'll be happy to tell you again. Okay? All right, so in F1, I'm going to put in x squared plus 4x plus 5. And then in F2 or Y2, I'm going to put in x squared minus 2x minus 6. So I've got one graph that's here-ish, right? And then I've got one graph that's here-ish. We've already spent a lot of time drawing exact, well, as close as a human being can get, parabolas, right? This is not the focus of this lesson. Notice how I said it's here-ish and it's here-ish? I know I made up that word. I don't care. I want you to get it close. Okay? What is our main focus point here? The intersection. Okay? Our main focus point is that point right there. And we have to remember how to do that. So I'm going to show you if you don't remember. Menu. Analyze. The intersection. There's only two graphs here, so I just have to get this on the left-hand side of the intersection and on the right-hand side of the intersection. Now, some of you can see yours very easily. I cannot. So remember that I can see my hand right there. It's like this. I can put that hand over the point that I want to grab. I can press Control and then the middle button, and it just grabbed. Did you see it go from open to closed? And I can move it somewhere where I can read it a little easier. So, negative 1.83, comma 1.03 is my solution. So, as also someone who's certified to teach English, I have a problem with this worksheet. Why? How many times does it cross? Except what does it ask for? Solutions. That implies that there's more than one, doesn't it? Plural. So please keep in mind this is trying to trick you. Don't allow yourself to be tricked. It's as easy as that. Okay? Sometimes there are multiple solutions. Sometimes there's not. So don't let yourself be tricked. If all we see is one solution, if all we find is one solution, there's just one. Fair enough? I'm not doing any more of those for you. You got that, right? Plug it in. Find the intersections. Okay. Look at number 10. Excuse me. Number 12. We don't get the option of solving this by graphing. Okay? And we have to be able to show our work that we're solving it algebraically and then confirm it by graphing it. But the work that I expect to see is the algebraic work. So if I don't see the algebraic work, you're not going to get full credit or anywhere near full credit. Okay? So how in the world am I going to solve these algebraically? So what you're saying is if y equals this and y equals this, we could set them equal to each other, can't we? What would happen? X squared plus 3x minus 5 equals 2x plus 1. One side would have to equal to 0 because we think it's a quadratic, right? Okay, so how about if we subtract 2x from both sides and subtract 1 from both sides? I get x squared plus x minus 6 equals 0. How in the world would I factor that, solve that? How about if I tell you the answer when I'm asking the question? How in the world would I answer this question? How can I solve it? Factoring, right? Do you know two numbers that multiply to be negative 6 and add to be positive 1? Positive 3, negative 2. x plus 3, x minus 2 equals 0. What do I do after I have that side factored? Very good. Set each factor equal to 0. Excellent. So x equals negative 3 and x equals 2. And then I'm done. Yay! Wait, are you raining on my parade? Because I was not telling you the truth, was I? I was trying to trick you. And you didn't let yourself be tricked. What do I have to do? Where do I have to substitute them? For the x back at the beginning or here somewhere? Like right here? No, not right here, right? Because there's no y right there. I know the x's. I got to find y. I got to go back somewhere where there's x's and y's. So one of those two, right? Which one would you choose? First or second? Probably the second one because it's easier. That's not a bad reason. Okay? If x equals negative 3, y equals 2 times negative 3 plus 1. I don't know why I put that over there. 2 times negative 3 is negative 6 plus 1? Negative 5. So when x equals negative 3, y equals negative 5. Y equals 2 times 2 plus 1. What is 2 times 2? 4. Excellent! Plus 1? 5. So when x equals 2, y equals 5. Is that how I should write my answers? This tells me that you know how to solve it algebraically. It doesn't tell me that you understand what they are. What are they? They are points of intersection, aren't they? So I need to write my answer like negative 3, negative 5, and 2, 5. That's my answer. Questions? How are you feeling about this? Meh. Okay, I can take that. Okay? Please circle the following problems. 2, 3, 6, 8, 10, 13, 15, 16, 18, and 20. Okay? Of course, the other ones that we did not circle, extra credit if you'd like to do those. Okay? I do have the answers on the screen. You have the rest of the period to work on this. I'm giving you time in class because you have to use a calculator for these, don't you? At least for the first half. Okay? So make sure that especially you get the first half done before you leave, and then be working on the second half if you already finished those. Are there any questions about this? Then tell me one more time before I leave you alone for a minute. Where is the solution to a system of equations? At the point of intersection. Very good. Okay, has everybody got that? I mean, I heard 3 people say it, but I need to make sure everybody understands it. Yes? All right, mark it, set, go. Peace.